Okay, good afternoon class. So today we're looking at probability. At this point you guys have completed for homework exercise on page 306, which deals with grade 8 to 12, grade 8 to 11 probability. Okay, so now we're going to look at the grade 12 section of probability. Okay. So we're looking at the example 1. For those of you who want to have a full lesson on this, you can find it in the description box below. Okay. So now we're looking at the fundamental counting principles. Okay. So consider the situation where you flip a coin and then roll a die. Okay. There are 4 possible outcomes in the situations. Okay. So firstly, for our coins, it can either be a heads or a tails. But even say heads, it can be either a 1 on your die, 2, 3, 4, 5 or 6. Hence, the reason why they got these 6 here on top. Then if your coin is flipped on the tails, then you have a combination of 6 outcomes there as well. Because they could have been a heads, a 1, a heads a 2, heads 3, heads 4, heads 5 and heads 6. Hence the reason why they got the second row there. Okay, which then gives me 12 in total, or 12 total outcomes here. Okay, so basically what I do is I introduce what we call bits. Okay, there's many ways of looking at this. Alright, so what I always do is I always make an allocation there for the number of outcomes in the first event and the number of outcomes in the second event. Okay. So if you're looking at tossing a coin, how many outcomes are there? 2. Which is heads or tails. How many outcomes are there on a die? 6. So 2 times 6 is 12. So we don't have to write all of the outcomes out for you to do to establish how many outcomes there are in total. You guys understand? Okay. So here we are told now the shortcut approach is called the fundamental counting principle. Okay, and can be stated in general as follows. So this is rule 1. I want you guys to write down. We're reading from page 308. I know it's different in your textbook, but in my textbook is the same. Okay, so it's page 308, and this is exercise 1 on page 308. Okay, so the rule says if one operation can be done in n ways, if one operation can be done in n ways, and the second operation can be done in n ways, which means to say your m value and your n value, your first operation and your second operation could be different or the same, then the total number of possible ways, different ways in which both operations can be done is m times n. Okay. So write that down quickly. Okay, so let's look at example 1, and example 1 is also on page 308. We are told that a meal can be made up as follows. Okay, choice 1, can have meat, fish or chicken. Choice 2, you can have chips, mash, baked potato, rice or vegetables. Okay, so where I'm from, we eat meat and chicken together. Okay, and chips and rice and others together. Okay, but you guys are different. You guys are normal. So you guys will have one of the following. Okay. They want to know how many different meals can be made using these choices. So how many bits will there be? Or how many? There will be two choices, not so many. In the first choice, how many? In choice 1, how many options do we have? 3 options. Not so much. In choice 2, how many options do we have? 5. There's going to be 3 times 5, which is 15. So there's 15 different meal combinations there. Can you see that, people? So we could have had chicken. Right? We saw the chicken. So it's chicken mash, chicken chips, chicken baked potatoes, chicken rice, chicken vegetables. So that gives you 5. If you go with fish, then it's fish and mash, fish and chips, fish and baked potato, fish and rice, fish and vegetables. Another 5, which gives me now 10 in total. That's all. And lastly, if it's meat, it's meat and mash, meat and chips, meat and mashed potato, meat and rice, or meat and vegetables. So it gives you another 5, which then gives me 15 in total. You guys understand? So there's 15 different ways of making up that meal. Okay? You guys understand? Right. Let's go to the next question. This is example 2. And this is example 2 also on page 308. Okay, that's a bit too big for the screen there. A gift pack can be made up as follows. Okay, so now we're making party packets. No? We'll give bag whatever. In choice 1, you can choose 1 CD out of a possible 4 different CDs. You guys know what the CD is? Yeah? You guys have your MP3 players and all of those things. Doesn't use CDs, no? Back in the day there were CDs and you put the movie on and all of those things. The CD is scratched and then you can't watch the movie. Okay, but anyway, there's there's 4 out of these 4 CDs to choose from in the first choice. The second choice, choose 1 packet of chips out of possible 5 different types of chips. Okay. Choice 3, 1 chocolate type out of a possible 12 different types. 12 different types of chocolates. No? Number 4, choose 1 type of fruit out of a possible 3 different fruit types. How many different gift packs can be made? So firstly, how many birds would I draw? The birds represents choices. No? I'm not going to tell you that all the time. Okay. So the birds represents choices. So I have 4 choices there. So it's going to be 4 birds. Okay. So what number would I put in the first bit of choice 1? Let's put 4. Not so. Choice 2? 5. Choice 3? 12. And choice 4? 3. So that simply would give us 4 times 5 times 3 times 12. We're going to answer 720. So there are 720 different ways I can make up this gift pack. You guys understand? Right. Let's go to the next question. Let's look at example 3. In example 3, we're going to consider the word Parktown. Okay? You are required to form different 8-letter word arrangements using the letters of the word Parktown. An example of the word arrangement would be, and there they gave you an example there. This arrangement of letters need not make any sense. Okay, so it doesn't need to make words that you are familiar with or proper English words. They want to know how many word arrangements can be made if the letters may be repeated. The letters may be repeated. What does that mean? That means to say I can have 2 P's. I can have 8 A's in a word. I can have 3 T's and 5 W's, for argument's sake. You understand? That is what it means when you say the letters may be repeated. So if I look at A, how many birds do you think I'm going to draw here? If there are 8 letters, 8. So it's 1, 2, 3, 4, 5, 6, 7, 8. So the question you should be asking yourselves, how many options do I have for the first bit if the letters may be repeated? How many options do I have for this first one? How many letters do you have? 8. Can I choose of any of those 8 letters? So how many options do I have? 8. Yes. So I can choose any one of the 8 ones. How many options do I have for the second letter? 8. Why? Because if I chose O in the first case, can I choose O again? Yes. Why? The letters may be repeated. Can I choose O in the third case again? Yes. In the fourth case? So how many options do I have in the next one? And the next one? And the next one? And the next one? So in other words, this is going to be 8 to the exponent. 1, 2, 3, 4, 5, 6, 7, 8. 8 to the 8. Which is a very large number. So 16,777,216. Okay. Let's look at B. The letters may not be repeated. Okay, if the letters may not be repeated, how many bits do you think I would have here? 8, yes. 1, 2, 3, 4, 5, 6, 7, 8, yes. How many options do I have in the first bit? 8. Now if I chose that O, can I choose it again? No. The letters may not be repeated now. So you are going to have 7, then 4, 3, 2. So in other words, that is going to be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. We're going to answer 40,303. Okay. So with that you should be able to do. Maybe just do the next one quickly. Now this still forms part of this example 4. Example 4, I want to know how many different ways are there of predicting the result of 5 rugby matches, where each match can end either in a win, a draw, or a loss. So how many bits do you think I'm going to draw here? There are 5 rugby matches. So you're going to be 5 bits. Okay. So how many outcomes is there for the first game? 3. Win, lose, or draw. So if they win the first game, can they win the second game? Yes. So how many outcomes are here? 3. And then? 3. And then? 3. And then? 3. So in other words, it's going to be 3 to the exponent? 5. And 3 to the exponent 5 is 2, 4, 3. Okay? So what that you should be able to do? Exercise 1 on page 310. People enjoy this every day. Good morning, good afternoon class.
Afternoon, sir.